In this movie, we're going to show you how to create a CNC part using a graphic image, which is going to be a bitmap. And this type of bitmap can be obtained by doing a Google search or buying a clipart library. And this gives you the type of image you can import and vectorize and create output for your CNC Plasma. So first thing we'll do here is go to the import button. We're going to go down here to a bitmap that's been saved and import it. And we can see here that this is a pretty pixelated piece of clipart. And there are two different types of vectorizing that we will typically use to convert this to a geometry. First, we've got to select our bitmap and then go down here to vectorize bitmap. We have enhanced curves, which works really well on this kind of a low resolution artwork. Or if you're scanning an image, you might be getting a few extra pixels here and there. And these type of filters will allow you to get rid of some of the unwanted pixels in areas that otherwise might not be filled out. But for this kind of image, we're just going to use enhanced curves. And there's a tolerance here that's going to help to remove some of the unnecessary points and give us a nice clean output on the machine. When we have the image here, we can select it and move it to the lower left-hand corner by hitting Control and 1 from the number pad. And we can actually just easily move it off there a little bit just to make it easier to see the boundary of the part. And we see blue and red contours. There's also the red contour of the plate. But the blue and red contours in this case tell us we have an outside contour and an inside contour. If we were to apply the path of this right now, we would be cutting outside of the blue and inside of the red to create the correct size image in between. Before we go ahead and do that, we're going to resize this part a little bit and make some changes to it. So first thing we'll do is come here and make this about a 15 by 15 inch part. And we could be very precise there, but we're still in the design phase, so I'm not worried about that little extra size. And I'm going to make this a rounded profile of this image instead of a square one. So we'll come here to the Draw Circle tool. Using the selection handles, it makes it easy to just click the first point in the middle and keep going out till we get to the edge to where we want it. And we're using the center and point method of drawing the circle. Now we want to get rid of this little component here, which is going to be the rectangular profile that was previously there. And I'm going to use the Cut by Line tool from the Weld menu to just cut these shapes right here above where the landscape starts. And now we can just select this image and we can see it turns pink because these are open contours now, and that tells us it's a little different than the blue and red closed shape from before. Now I can select on this circle and we're going to go to the Inline Outline tool and we can specify the amount here, and you see a little preview here. We actually do want a 1 inch inline outline, so we're going to hit Apply. And that leaves us with some contours that are overlapping. And we can go to the Draw menu and go to Trim, which will automatically take us to the By Boundary section. And we can put the cursor right over top of the lines we want to get rid of. They turn blue and we can get rid of them. So in this manner, it was pretty easy to convert this from a rectangular profile shape into a round one. And we can see there's still some pink contours here, which tell us they're open contours. And we're going to right click on those and go to Merge Selection, which can also be found under the Transform menu. And using a tolerance here, which can help jump any openings, we're going to convert this back into two blue and red closed shapes. And we can also come here and do a little cleanup again, just to make sure that we have a nice smooth, and get rid of any unnecessary points, have a nice smooth transition around all the points. So now that we have our design, we might want to do one more thing here and add a little bit of text. So we're going to come here to the Text tool. And the Text tool typically is going to have some variables here related to assigning any parts. And we'll come here and select a particular type of font here. Actually, we'll go ahead and use this previous font here. And if we select one of the geometries here, rather than an open space, rather than to be a horizontal text and vertical text, it's going to follow the path of the geometry. So now we're going to type something in here. Let's type in, and there are a few variables here that exist for any given text that's been created. We can see here actually this has got a little bit of kerning to it, and we can increase our kerning just by hitting the increase button. We can also come here and move this so that it'll be right at the same start point, or maybe just a little bit below where this outer border starts. So now that we have our text in place, we can come here also and go to the middle function here of the text tool, which is to edit the text. And this gives us some handles that we can use to drag the text around and come in here and move it around. Now I'm going to come here before we do anything else and make this text just a little bit bigger, since we seem to have a little space to do that. And you can see that it gets bigger right on screen as we make those changes. And one last time I'm going to come here and adjust the positioning just to make sure I have it where I like it. Once this text is done, we're going to take it and convert it from text, and we're going to convert it into lines and arc. So this now is no longer a font that we can correct or change. We can now just modify the geometries like we could any geometries. And one of the ways we're going to do that is we're going to come here to the transform menu and put a little noise distortion on there. And there's a couple types of distortion. The noise distortion will just make this look not quite such a perfect font. It'll make it look a little bit rustic. So let's come here, and we've got a few variables here, a wavelength and some jitter and horizontal amplitude. When I hit apply, we can see that there were just some minor changes that occurred to the text. Now, one other thing we need to consider here is if we select all this text, everything we're going to cut, we're going from blue to red, which is inside and outside. But we still have two more blue parts here, and that would be a problem because these would be freestanding pieces that can fall away. So I have to have some way to address this. And what I'm going to do is do a little bit of manipulation of the parts. So we'll come back to the point edit tool, and we're going to come here and just cut right here. We can use the snap tool and cut right on that corner. And then we're going to create another little part here with a slight angle that's going to create the tab that keeps the middle part here from falling out. Now that I've removed that, I can go to the join contours, and we can just join those two parts back together. And we can always do a little point editing here. We're just going to go to point edit mode and maybe get rid of some extra bumps there. So that's how we're going to get rid of that little part for the R. Now let's go here to the A, and we'll do something similar. We're going to go to the cut by line function, cut the line right there, cut the line right here, and go across this area. Now we can delete these little parts that we've cut away, and we can rejoin these other sides with the join contours. And depending upon how much of a rustic look there, we can have those points be straight or not. Now when we select this part, we see we have blue and red, and that's what we want to see to make sure we don't have any parts that are going to fall out or be freestanding parts when the job is cut. Now the next thing we can do is move this into the plate, and we could do that after the path has been applied, but we'll go ahead and do that now. And select both of the contours. We're going to go to the toolpath menu and apply a kerf compensation. The kerf compensation is going to allow us to account for the amount of material removed or the kerf removed during the cutting process. And with most plasmas, it could be around 0.03 to 0.06, depending upon what type of plasma you're working with. So we're going to use 0.06. We're telling it to do an internal command. It can also be external. We can have a feed rate here, or we can control the feed rate through the controller. And there are some entry-exit parameters that can be adjusted. Once everything is set up, it can be saved as a template and easily reused without having to enter all this data every time. When the OK button is clicked, a path is created based upon the defined kerf compensation, and we can see the path here represented in blue with arrows showing you the direction of travel. If you hit F9, it'll show you the amount of kerf to be removed in a visual manner. We can also see the green entry-exit points, which are the pierce points for any of these parts. And we want to just go through here and quickly make sure that everything looks good. Because we used in the preferences, which you can get to by F10, we used here the longest segment in the middle. That reduces the likelihood that the part's going to cut in a bad area. One thing we might want to do is come up here and check on these. And we might be able to improve this just a little bit by coming here and going to Edit Entry Exit and see if this will be enough. If not, we might need to come back here, quickly remove the toolpath, which is just hit remove toolpath here, and make just a little bit more room here for these parts to have the path be inside there, which is part of the process of cutting something and designing something that's graphical in nature, and oftentimes will require a little bit of extra work to make sure that the path can fit in there. This isn't always the case. It just depends upon how detailed any given object is going to be. So we just made these two parts a little bit bigger with some simple point editing. Then we'll select the parts again, go back to Kerf Compensation, which will always remember your last settings, and reapply these values and make sure everything looks okay. For the most part, everything's okay here, but we might want to go ahead and just change this one more time to move that into the biggest part here. And we could also change the entry-exit parameters a little bit if needed. Once we feel like this part is going to be okay for cutting, then it's time to create the CNC output. I can come here and move it maybe away, just a little bit away from the edge of the part. So we're using the move part of precision input to move it away just a little bit. We can change the plate size a little bit. Here we have 3/16 inch plate size. And now we're ready to create the output. So we have a WinCNC driver set up here for Plasma, and we're going to create output by going to the machining menu and going to output. We hit the to file button, and we're going to name this file Ranch Life. Once the output is created, we can verify it by going here to the solution menu and going to backplot. Backplot is a little G-code previewer that will allow you to open the file and make sure that the output looks okay, that there's not too many control points, and that the resulting cut will give you a good edge quality. And you can also come here and just by looking at the color of the lines, you can see what's going to be an arc cut and what's going to be a straight line cut. Straight line showing up as blue. So this is just a good way to verify the toolpath after it's been created, and you're now ready to cut the part on the CNC. This is an example of how to create a CNC part using a graphic file with EnRoute software.